The universe is deceiving us. It tells us through equations that wormholes exist, and tells us through the laws of physics that wormholes cannot be used. In 1935, the day Einstein solved the wormhole equations, he fell into deep self-doubt, because the solution was too perfect. So perfect that it felt like a carefully designed trap. He told his student Rosen that the result was insane. That spacetime could be punctured like a bedsheet. That two places separated by 10 billion light-years could be connected by a single bridge. Even more outrageous is that crossing this bridge would theoretically take an instant, while taking the normal route, even light would need 10 billion years. That bridge later became known as the Einstein-Rosen bridge. In other words, a wormhole. But then comes the most terrifying question. This thing is theoretically perfect, mathematically flawless, yet physically it collapses into a point. In less than 1/10,000th of the time it takes you to blink, anything that tries to pass through it would be instantly torn apart into particles. Some time ago, a video by a Nobel Prize winner describing wormholes went viral again, and when he mentioned that wormholes cannot form naturally, the comment section almost turned into a place of worship. Once again, people said the end of science is metaphysics. But have you ever thought about this? Why does something derived from an equation turn out to be so absurd? Why would the universe bury a backdoor in its physical laws that can never be used? Are wormholes a joke played by nature? Or do they hide an ultimate secret we don't yet understand? Let's first answer the opening question. Why do wormholes close instantly? To explain that, we have to start with the nature of spacetime. Einstein told us that spacetime is not rigid. It is like an elastic rubber membrane. If you place a bowling ball on it, the membrane sinks. That dent is gravity. Earth makes a small dent. The sun makes a large one. And a black hole punches straight through the membrane. What about a wormhole? It's even more extreme. It's as if you use your hands to pinch together two distant points on the membrane and poke a hole to connect them. Theoretically, it's perfect. But then the fatal problem appears. The rubber membrane has elastic recoil. The moment you let go, the hole snaps shut at nearly the speed of light, so fast that even light can't make it through. Physicists have calculated that from opening to closing, a wormhole may exist for only 10 to the minus 43 seconds. That is Planck time, a trillion times faster than a blink. Anything that tries to pass through would be instantly crushed into quantum fragments. In 1988, Nobel laureate Kip Thorne and his student Morris published a sensational paper in Physical Review Letters. They said they had found a solution. You need something called exotic matter to hold a wormhole open. How exotic is it? Its mass must be negative. Note, this is not antimatter. Antimatter still has positive mass, only opposite charge. Exotic matter has truly negative mass. If you push it, it doesn't move forward, it moves backward. It completely violates Newton's third law. It's like pushing water with a stick, and instead of flowing away, the water rushes toward you. That is the strangeness of negative mass. Thorne's team proved that this kind of matter can produce reverse gravity. Instead of pulling spacetime inward, it pushes it outward. Exactly what's needed to counteract wormhole collapse. Sounds like magic, right? But it gets even stranger. Back in 1948, the Dutch physicist Casimir predicted that negative energy might actually exist. He said that if you place two uncharged metal plates extremely close together in a vacuum, the vacuum itself will push them together. Why? Because the vacuum isn't empty. It's full of quantum fluctuations. Countless virtual particles are constantly popping in and out of existence. Between the two plates, the space is so narrow that long wavelength virtual particles can't fit. The energy density there is lower than outside, creating a region of negative energy. In 1996, scientists at Los Alamos National Laboratory in the United States actually measured this force. Its strength was about 1/30,000th the weight of an ant. This proved one thing: negative energy is not fantasy. It truly exists in the laboratory. The Casimir effect excited physicists for several years, but reality soon hit them like a sledgehammer. Can you guess how much negative energy is needed to keep a wormhole 1 kilometer in diameter open? The answer will make you question existence. The mass of an entire solar system, and it has to be negative. What does that even mean? The Sun alone accounts for 99.86% of the total mass of the solar system. Add Jupiter, Saturn, Earth, and all other planets, plus the combined mass of asteroids and comets. And how much negative energy does the Casimir effect provide? The negative energy density between two plates is only enough to hold open a wormhole, 1/10,000th the size of an atomic nucleus. It's like trying to dig a tunnel through the Himalayas, with nothing but a toothpick in your hand, and expecting it to support the entire mountain. When NASA scientists finished running the numbers, their conclusion came down to two words: utter despair. This discovery almost pronounced the death sentence for wormholes. Negative energy exists, but the scale required is off by astronomical orders of magnitude. Humanity will never be able to gather that much exotic matter. Many physicists began to believe that wormholes are like perpetual motion machines. They don't violate physical laws in theory, but in reality, they can never be built. But science is always like this. Just when you think you've hit a dead end, a new path is often hidden around the corner. In December 2022, the cover of Nature exploded. A team from the California Institute of Technology, using Google's quantum computer, claimed they had created the first wormhole in human history. Of course, this was not a real space-time wormhole, but a quantum simulation of a wormhole. They created a pair of entangled qubits on a quantum chip, then fed information in from one side. The result: the information emerged on the other side, without traveling through space in between. This experiment was based on a bold conjecture, called ER=EPR, proposed in 2013, by Susskind at Stanford and Meldacena at Princeton. Put simply, wormholes, the Einstein-Rosen bridges, ER, and quantum entanglement, EPR, may be two manifestations of the same thing. How radical is that idea? What is quantum entanglement? Two particles, no matter how far apart. When you measure one, the other responds instantly. Einstein famously called it spooky action at a distance. If wormholes are the geometric embodiment of quantum entanglement, what does that mean? It means the essence of wormholes may not be a gravity problem at all, but a quantum problem. We've been trying to open wormholes the wrong way, like using a mechanical key to open an electronic lock. Google's experiment, although only a simulation, opened a brand new door. Maybe one day, we really can use quantum entanglement to construct real wormholes, without needing that impossible exotic matter. Just as the world was focusing on the quantum approach, Professor Dai Dechang's team, at Yangzhou University in China, published a completely different idea in 2023. In the European physical journal C, they said stop trying to build wormholes inside four-dimensional spacetime. Step outside and think in higher dimensions. What if our universe is a three-dimensional membrane, embedded in higher-dimensional space? Like drawing 2 points on a sheet of paper. They look far apart, but if you fold the paper, the 2 points touch. Professor Dai's team calculated that if two parallel brain universes exist, gravitational interaction between them could deform the brains. Two massive objects could bend their respective brains until they attach to each other, forming a connecting channel. This would be a wormhole-like structure. Their calculations show that, under specific conditions, two objects with the mass of the Sun could indeed form a stable wormhole-like structure. No exotic matter required. This research was published as a cover article, opening a third path for wormhole research. Have you noticed? The history of wormhole research is really the history of humanity, constantly hitting limits and then finding new ways forward. In 1935, Einstein said wormholes would close instantly. In 1988, Thorne said exotic matter could hold them open. In 1996, the Casimir effect proved negative energy exists but isn't enough. In 2013, the ER=EPR conjecture shifted the problem to quantum entanglement. In 2022, Google successfully simulated one with a quantum computer. In 2023, a Chinese team proposed the brain-universe approach. Every breakthrough overturns the conclusion before it. That is the true charm of science. Now we can answer the opening question. Why would wormholes be a backdoor, buried by the universe that can never be used? Because maybe they were never meant for travel. They are a question the universe left for us. A question whose answer hides the secret of how quantum mechanics and general relativity can be unified. It hides the truth about the nature of spacetime, and the answer to how many dimensions our universe really has. Wormholes are like a mirror, reflecting the boundaries of human knowledge. They stand there quietly, waiting for the day when we truly understand the essence of spacetime and the quantum world. Only then will they open to us. 100 years ago, when black holes were predicted, no one believed they really existed. Until in 2019, humanity captured the first image of a black hole. 50 years ago, gravitational waves were a joke. Until in 2015, the LIGO detector truly observed them. Every one of Einstein's crazy predictions has been verified by time. Will wormholes be next? Perhaps in some dimension we cannot yet see. In some fold of higher dimensional space, wormholes truly exist, connecting corners of the universe that seem impossibly distant. The universe does not deceive us. It simply saves the hardest riddles for the end. The existence of wormholes tells us that reality is always more magical than imagination, and humanity's pursuit of truth will never stop. So here's the question. If one day, wormholes are truly proven to exist, Where would you want to use one to go? Back to the past, to change a regret, or into the future, to see humanity's fate? Write your answer in the comments. See you next time.